Most gears spin fast to keep machines moving, but the worm gear takes a different path. It slows everything down to unlock incredible force. Worm gears, the crawler that carries giants. A worm gear has two parts, a screw-shaped shaft, called the worm, and a wheel with teeth cut around it. As the worm turns, its spiral thread pushes against the wheel's teeth, driving it forward. It's a simple design, but it works in a way unlike any other gear. Each time the worm makes a full turn, the wheel only moves forward by a single tooth. That means it takes many turns of the worm to spin the wheel once. The payoff is a massive reduction in speed and a surge in torque, turning quick input into heavy, controlled output. One of the worm gear's biggest advantages is that it's self-locking. The wheel can't easily turn the worm backwards. That means once it stops, it stays put, like a gear with a built-in brake. This natural resistance makes worm gears perfect for jobs where holding steady is just as important as moving. You'll find worm gears in places both big and small. In the tuning pegs of guitars, they keep strings tight without slipping. Some elevator designs make use of worm gears as part of their machinery. And in satellite dishes, worm gears provide the precision and holding strength to keep signals locked on target. Here's a not-so-interesting fact. You'll often find worm gears inside motorized swing gates, chosen for their ability to hold position, deliver high torque, and keep the mechanism compact and reliable. It's one of those quiet design choices that makes everyday automation work smoothly. From strength to control, worm gears prove that even the simplest shapes can solve big problems. Next time, we'll explore the rack and pinion, the gear that trades spin for movement in a straight line. Until then, stay curious, stay tuned, and don't forget to subscribe for more.